Biology has woven a profound biological necessity for being alone into the very fabric of our neurological architecture. While we are often categorized as an obligate social species, the human brain requires intervals of isolation to maintain its delicate chemical and structural equilibrium. You may find it interesting to subscribe for more science for sleep as we examine how the body differentiates between the physiological state of solitude and the psychological distress of loneliness. These two states exist on opposite ends of a neurobiological spectrum. Loneliness triggers a survival-based stress response, spiking cortisol and activating the dorsal anterior cingulate cortex, the same region associated with physical pain. In contrast, intentional solitude facilitates a shift in the brain's energetic priorities, allowing the central nervous system to move from an outward-facing, reactive stance to an inward-facing, restorative one. When you remove the constant pressure of social stimuli, your brain shifts its metabolic focus toward the default mode network. This complex circuit, involving the medial prefrontal cortex and the posterior cingulate, becomes highly active when we are not focused on the external world. It is during these quiet windows that the brain engages in autobiographical memory processing and the consolidation of complex information. Research suggests that the absence of others allows the brain to escape social monitoring, a demanding cognitive task where we subconsciously track the expressions, tones, and expectations of those around us. By shedding this overhead, the prefrontal cortex can divert its limited glucose reserves toward creative problem-solving and self-integration. The cognitive benefits of being alone extend deep into our physical health, impacting everything from heart rate variability to cellular repair. In our current landscape of early 2026, clinical studies continue to validate that brief, regular periods of solitude can lower systemic inflammation markers. This isn't about isolation in a negative sense, but rather about the strategic withdrawal from the herd to allow the amygdala to downregulate. When the brain realizes it is safe and unobserved, it enters a unique state of neuroplasticity. This script explores the verifiable cognitive and physical advantages of spending time apart, providing a foundation for why your mind thrives in the stillness. We are tracing the path from the ancient evolutionary roots of quietude to the modern neurological discoveries that prove being alone is a vital component of human peak performance. Distinguishing between the objective state of being physically by oneself and the subjective experience of feeling disconnected is the first step in understanding the neurological benefits of quietude. In clinical psychology, researchers often separate positive solitude, a state of chosen self-governed isolation, from social isolation, which is typically marked by a lack of desired contact and a measurable increase in cortisol production. This distinction is vital because the brain processes these two states through entirely different neural pathways. Positive solitude activates the default mode network in a way that encourages self-reflection and creative synthesis, whereas forced isolation often triggers the amygdala, signaling an evolutionary survival threat. Psychologists utilize a concept known as constructive non-engagement to describe the period where an individual is not interacting with others or performing a specific social role. This state is not synonymous with boredom or inactivity. Rather, it is a deliberate withdrawal from the external stimuli that usually dictate our behavior. Have you ever noticed how your thoughts seem to reorganize themselves when you are simply sitting in a room without a phone or a book? During these intervals, the brain engages in autobiographical planning, allowing the subconscious to consolidate memories and project future scenarios without the interference of social judgment or peer expectation. Measuring the quality of this time requires more than just a stopwatch. Scientists often use the experience sampling method to track how individuals feel during specific moments of alone time throughout their day. Data from 2024 and 2025 studies suggest that the most beneficial solitude occurs when the person feels they have complete autonomy over their environment. This autonomy allows the prefrontal cortex to relax its focus on social monitoring, which is a metabolically expensive process. When we are alone, the pressure to perform a social identity vanishes, reducing the cognitive load and freeing up resources for deep, divergent thinking. There is, however, a critical threshold where the benefits of being alone begin to diminish. While the initial stages of solitude promote psychological restoration, prolonged periods without any social tethering can lead to a phenomenon known as social hunger. The brain begins to prioritize social cues over internal reflection, seeking out any form of connection to maintain emotional equilibrium. Researchers at the University of Virginia found that most people derive the greatest cognitive benefits from solitude when it is balanced with regular, high-quality social interactions, creating a rhythmic oscillation between engagement and withdrawal. This brings us to the solitude paradox, an observation that many people tend to underestimate how much they will enjoy being alone until they are actually in the midst of it. Before entering a state of solitude, the brain often predicts boredom or anxiety, creating a sense of dread that discourages the behavior. Yet, once the period of quietude begins, the intrinsic rewards of mental clarity and emotional regulation often exceed those initial expectations. Understanding this cognitive bias allows for a more intentional approach to scheduling time for oneself. It helps us bypass the initial resistance of the mind, acknowledging that the stillness waiting on the other side of the door is not a void, but a workspace for the soul. The transition from social engagement to individual retreat is not a modern luxury, but an ancient survival mechanism etched into the human genome. During the Pleistocene epoch, our ancestors discovered that while the group provided defense, the individual provided innovation. Archaeological evidence from sites across the Levant and southern Africa suggests that specialized tool production often occurred in peripheral zones, away from the central hearth of the settlement. When an early human engaged in the delicate process of pressure flaking a spearhead, the presence of others was a distraction that could lead to a ruined piece of obsidian. This requirement for deep focus necessitated a physical and psychological distancing that anthropologists call functional privacy. By stepping away from the chatter of the tribe, the individual could enter a state of cognitive flow, mapping out the multi-step sequences required for complex tool assembly. Have you ever found that your best ideas come to you when you are walking alone, far from the demands of others? This phenomenon mirrors the early human practice of scouting, where solitary hunters would range miles ahead of the group. In these moments of isolation, the brain shifts its processing from social navigation, monitoring the moods and hierarchies of the group, to environmental scanning. This shift reduces the metabolic load on the prefrontal cortex. Constant social vigilance, known in evolutionary biology as the social monitoring cost, requires significant glucose and oxygen to maintain. Solitude acts as a metabolic reset button. When we are alone, the amygdala's sensitivity to social cues can downregulate, allowing the default mode network to engage in what researchers call autobiographical planning. For a hunter-gatherer, this meant mentally rehearsing the geography of a valley or predicting the movement of a herd based on subtle environmental shifts that would be missed in a social setting. Anthropological studies of modern hunter-gatherer societies, such as the Hadza or the Sand People, reveal specific cultural retreat rituals. These are not merely spiritual. They serve as critical intervals for resource assessment and internal recalibration. In many of these cultures, individuals will spend hours or even days on the periphery of the camp. This behavior allows for a balance between social cohesion, which ensures protection, and individual survival strategies, which ensure that no single person becomes a drain on the group's collective energy. The biological cost of constant sociality in early human history was exceptionally high. Being constantly observed by peers triggered a persistent, low-level stress response designed to keep the individual's behavior within the group's norms. This vigilance was exhausting. Evolutionarily, those who could successfully navigate the balance between group participation and strategic isolation were more likely to survive and pass on their genes. They were the ones who could think ahead, plan for scarcity, and return to the tribe with new insights gained from the silence of the wilderness. This ancestral need for privacy remains a biological imperative today. Even though our environment has changed from the savanna to the city, the neurological machinery remains the same. The brain still seeks those periods of low social noise to perform deep maintenance and long-term planning. The social brain hypothesis, proposed by Robin Dunbar, posits that human intelligence evolved primarily to manage complex social relationships, yet the energy required to track these relationships is immense. In the absence of others, the brain is liberated from theory of mind processing. This liberation allows the brain to redirect energy toward extractive foraging tasks, which require intense spatial memory and causal reasoning. This legacy explains why the absence of others feels less like a void and more like a return to a fundamental state of clarity. This interior focus is governed by a complex circuit known as the default mode network, or DMN, which acts as the brain's primary autopilot system. When you cease engaging with external stimuli, this network, comprised largely of the medial prefrontal cortex, the posterior cingulate cortex, and the angular gyrus, surges into a state of high metabolic activity. It is a biological paradox that the brain remains remarkably busy while you are ostensibly doing nothing at all. Neuroscientists have observed that the DMN is essentially the seat of the self, facilitating the construction of personal narratives and the simulation of future scenarios. The activation of this network is governed by an inverse relationship with the task-positive network, which handles goal-oriented actions. As your focus on a specific manual or cognitive task fades, the task-positive network goes quiet, allowing the DMN to take the helm. This toggle is not just a shift in attention, but a complete redistribution of neural energy across the cerebral landscape. While the brain represents only about 2% of total body weight, it consumes 20% of your oxygen and calories, with the DMN accounting for a staggering portion of that energy expenditure even during rest. Functional magnetic resonance imaging, or fMRI, has provided visual proof of this phenomenon, showing these specific hubs glowing with activity the moment a subject enters a state of solitary quiet. These scans reveal that the DMN is most robust when we are alone, free from the immediate demands of social interaction or external problem solving. It is during these moments that the brain begins to synthesize disparate pieces of information, a process crucial for creative breakthroughs. Do you find that your most innovative ideas tend to surface when you are in the shower or walking alone, rather than during a busy workday? This internal chatter is not mere noise. It is the brain's way of maintaining its cognitive architecture through a process called synaptic homeostasis. By revisiting past experiences and projecting potential futures, the DMN helps solidify your sense of identity and place in the world. Research published in the journal Nature indicates that the DMN's connectivity is a strong predictor of an individual's ability to engage in divergent thinking, which is the capacity to generate multiple solutions to a single problem. Without the periodic dominance of the default mode network, our ability to understand the motivations of others, a skill known as mentalizing, would likely wither. This is because the same neural pathways used to reflect on our own lives are recruited to imagine the internal states of those around us. Solitude, therefore, serves as a necessary rehearsal space for the complexities of social life, allowing the DMN to calibrate and update our internal models of reality. Even when you are lying still, perhaps listening to these facts as a form of bedtime listening, your DMN is diligently organizing your memories and emotional responses. This metabolic investment suggests that doing nothing is a misnomer. It is actually a period of intensive internal maintenance. The sheer volume of energy dedicated to this network underscores its evolutionary importance for survival and high-level cognition. By stepping away from the noise of the world, you are effectively handing over the keys to a sophisticated biological processor that works best in the absence of interruption. This biological processor relies heavily on the default mode network to engage in what neuroscientists call autobiographical planning. During these periods of isolation, your brain is not merely resting, but is actively sorting through the narrative arc of your life. This internal maintenance allows for the integration of disparate experiences into a cohesive story that defines who you are. The medial prefrontal cortex acts as a central hub during these moments, synthesizing past memories with present circumstances to create a roadmap for your future self. Solitude provides the necessary environment for constructing a consistent sense of self over long durations. Without the influence of others, the brain can process information specifically related to the self without the distorting noise of social expectations or the pressure to perform a specific persona. This process ensures that your core values and beliefs remain stable even as external circumstances fluctuate. Research suggests that people who spend regular time alone are often more resilient because their self-concept is rooted in internal reflection rather than the shifting sands of external validation. Think about the last time a conversation stayed with you long after the other person left the room. This post-social processing is a critical function of being alone, allowing the brain to deconstruct social cues and verbal exchanges without the immediate requirement of a real-time reaction. In the heat of interaction, the executive control network is preoccupied with generating immediate responses, which often prevents a deep analysis of subtext or emotional resonance. Solitude grants you the cognitive bandwidth to understand your own reactions to others, effectively sharpening your social intelligence for the next time you step into the world. Silence serves as a primary launchpad for mental time travel, a phenomenon where the brain projects itself across various temporal planes. While you sit in a quiet room, your mind is likely wandering through prospection, which is the ability to simulate complex future scenarios and weigh their potential outcomes. This isn't just idle daydreaming. It is a sophisticated survival mechanism that prepares the organism for challenges that have not yet occurred. By simulating these events in the safety of solitude, the brain reduces the metabolic cost of trial and error in the physical world. The modern era of constant digital connectivity acts as a persistent interruption to this vital self-reflection loop. Every notification or scroll through a feed pulls the brain out of its internal processing mode and forces it back into an externally oriented, reactive state. This prevents the default mode network from completing its cycles of autobiographical consolidation, which can lead to a fragmented sense of identity over time. When we sacrifice solitude for digital presence, we are essentially pausing the deep work of self-evolution in favor of superficial stimulation. Maintaining this internal loop is essential for psychological health and cognitive clarity. Without these moments of self-referential thought, the brain struggles to update its internal models of the world. By intentionally seeking out time away from the crowd, you allow your neural architecture to perform the necessary house cleaning that keeps your personality distinct and your goals clear. This is the quiet work of becoming who you are, performed in the silence that only solitude can provide. When we step away from the noise of the world, our brains enter a state known as wakeful rest, which is fundamentally different from passive inactivity. During these periods of solitude, the brain's default mode network becomes highly active, facilitating a type of internal housekeeping that is impossible during focused tasks. This network, centered in the medial prefrontal cortex and the posterior cingulate cortex, engages in self-referential thought and the synthesis of past experiences. It is a period of neural maintenance where the brain begins to reorganize its internal priorities without the pressure of an immediate external goal. Recent insights from 2025 highlight how this state allows the hippocampus to replay recent memories, effectively tagging them for long-term storage even before we fall asleep. In the absence of social interaction, the brain begins to downregulate the processing of incoming sensory information. The thalamus, often described as the brain's gatekeeper, reduces the volume of external stimuli it passes to the cortex, allowing the internal neural environment to dominate. This shift reduces the cognitive load significantly, preventing the mental fatigue that often stems from constant environmental monitoring. When you choose to be alone, you are essentially giving your sensory systems a chance to recalibrate their sensitivity thresholds. This reduction in input allows the brain to divert energy away from the primary sensory cortices and toward the associative areas where higher-order thinking occurs. Research through 2024 and 2025 has expanded our understanding of how quiet wakefulness may even assist in the clearance of metabolic waste products. While the glymphatic system is most active during deep sleep, the relaxed state of solitude facilitates a more efficient flow of cerebrospinal fluid compared to high-stress, high-arousal states. This gentle flushing of the interstitial space helps remove byproducts like adenosine and certain proteins that accumulate during intense cognitive activity. By doing nothing, you are actively facilitating a cleaner, more efficient neural environment. This process ensures that the brain does not become overwhelmed by the molecular debris of its own metabolic processes during the waking day. It is important to distinguish this solitary wakeful rest from the physiological state of sleep. While sleep focuses on the consolidation of declarative memory and physical tissue repair, quiet solitude allows for the integration of emotional experiences and complex problem solving. It is a unique window of consciousness where the mind remains alert enough to forge new connections, but relaxed enough to ignore the constraints of logic. This specific state of neural recovery bridges the gap between the frantic energy of the day and the total unconsciousness of the night. Do you find that your best ideas often arrive when you are simply staring out a window or sitting in a quiet room? This is the brain capitalizing on the lack of external demand to solve problems that were previously sidelined. the chemistry of the brain shifts noticeably in a low-stimulation environment. Levels of norepinephrine, the neurotransmitter associated with alertness and stress, begin to decline, allowing the nervous system to shift from a sympathetic state to a parasympathetic dominance. This transition supports a healthier balance of GABA, the brain's primary inhibitory neurotransmitter, which helps to quiet overactive neural circuits and reduce the baseline of anxiety. Furthermore, the brain's reward system resets its sensitivity to dopamine during these periods of low external input. Such a chemical recalibration ensures that when we do return to the busy world, our reactions are measured and our focus is sharp. The electrical rhythm of the brain undergoes a profound transformation the moment we step away from social demands and enter a state of true solitude. In the presence of others, the human brain typically operates in the beta frequency range, which spans from 12 to 30 Hz. This high-frequency state is essential for active processing, logical reasoning, and the high-level cognitive alertness required to navigate complex social interactions and environmental stimuli. However, as the external noise fades and the subconscious pressure of social performance dissipates, our neural oscillations begin to slow down and transition into the alpha range. These alpha waves, oscillating between 8 and 13 Hz, represent a functional bridge between the analytical conscious mind and the more intuitive subconscious layers. Neurological research has identified this specific alpha state as a condition of relaxed alertness, where the mind remains remarkably awake but is no longer held in a grip of hypervigilance. It is a state that facilitates creative problem-solving and complex memory integration, occurring naturally during periods of quiet reflection. While you listen to these relaxing facts to help you fall asleep, do you notice how your own internal dialogue shifts when the environment becomes still? This transition is not merely a passive lack of activity. It is a specialized, active mode of neural operation that cleanses the mental palate. Unlike the often fragmented patterns of high beta waves, alpha waves indicate a brain that is primed to process internal information without the constant interference of environmental stressors. In deeper moments of sustained solitude, the brain may even begin to dip into the theta range, which is frequently associated with profound intuition and the elusive flow state. One of the most remarkable phenomena occurring during these solitary intervals is the increase in neural synchronization. When we are alone and undisturbed, the electrical signals between the left and right hemispheres of the brain begin to align with greater harmony. This hemispheric coherence allows for more efficient communication across the corpus callosum, the dense bundle of nerve fibers connecting the two sides of the brain. Evidence suggests that this synchronization is vital for long-term cognitive flexibility and the stabilization of emotional responses. This shift in brain wave frequency eventually triggers a cascading effect throughout the entire autonomic nervous system, leading to a measurable reduction in systemic cortisol. When the amygdala perceives that there is no longer a need to scan the environment for social cues or potential judgments, it signals the endocrine system to dampen the production of stress hormones. This physiological reset allows the parasympathetic nervous system to regain dominance, gently lowering the heart rate and stabilizing arterial blood pressure. Science for sleep often highlights how these quiet periods of neural synchronization are when the brain performs its most essential metabolic maintenance and prepares the body for deep rest. The constant act of decoding human presence represents a significant metabolic tax on the central nervous system. When we are in the company of others, the brain must continuously prioritize high-bandwidth data streams, such as the rapid-fire shifts in a companion's pupil dilation or the nearly imperceptible tremors in their vocal pitch. This process is managed largely by the fusiform face area and the posterior superior temporal sulcus, regions that work tirelessly to interpret social intent from a sea of visual and auditory noise. Even a casual conversation requires the prefrontal cortex to exert immense inhibitory control, filtering out irrelevant stimuli to maintain focus on the exchange. This neurological exertion is what scientists often describe as the biological cost of sociality. The brain is effectively a prediction engine, and in social settings, it is forced to run complex simulations of what others might think, feel, or do next. When these external inputs are removed, the cognitive load drops precipitously, allowing the metabolic resources usually reserved for social vigilance to be redistributed toward internal repair. This shift marks the transition from active external monitoring to the restorative state of social destimulation, a phase where the brain's energy consumption patterns change fundamentally. Have you ever noticed how your face feels slightly different, perhaps even heavier, after several hours of complete solitude? This sensation is rooted in the physical relaxation of 43 distinct facial muscles that typically remain in a state of low-level isometric tension when we are being observed. This social mask is not merely a psychological construct, but a physiological reality involving constant microcontractions that hold the brow, mouth, and eyes in socially acceptable positions. In the absence of an observer, these muscles finally undergo mechanical unloading, which reduces the constant stream of sensory feedback to the trigeminal nerve and helps signal to the rest of the body that it is safe to descend into a deeper state of rest. Beyond the musculature, being alone provides a unique reprieve for the amygdala, which serves as a sentinel for social threats or hierarchy shifts. In solitude, the amygdala's firing rate tends to stabilize, leading to a measurable reduction in circulating cortisol levels. This biochemical environment is essential for neuroplasticity, as it allows the brain to process the day's events without the interference of new, high-stakes social data. The reduction in sensory input facilitates a more efficient neural synchronization across the cerebral cortex, which is a hallmark of high-quality science for sleep. The neurological phenomenon of social fatigue is often the result of the brain's social processing centers reaching a point of saturation. By removing the requirement to interpret body language and linguistic nuances, we allow the executive functions of the brain to enter a standby mode. This does not mean the brain is inactive. Rather, it shifts its focus from the external to the internal, engaging the default mode network to consolidate memories and reinforce the sense of identity. This internal housekeeping is only possible when the high-bandwidth demands of social interaction are silenced, making the physiology of being alone a vital component of long-term cognitive health. The central mechanism behind this restoration is the autonomic nervous system, a complex regulatory network that maintains the delicate equilibrium between action and recovery. In the presence of others, the human brain often maintains a state of subtle hypervigilance, an evolutionary carryover where social monitoring keeps the sympathetic nervous system, the fight-or-flight branch, constantly engaged. This state is not necessarily one of overt stress, but rather a persistent readiness to respond to social cues, microexpressions, and the expectations of peers. When this social pressure is removed, the sympathetic drive recedes, allowing the parasympathetic nervous system to assume dominance. This shift, often referred to as the rest and digest state, is a fundamental biological reset that redirects metabolic energy away from external alertness and toward internal cellular repair and systemic maintenance. Clinical research into psychophysiology has demonstrated that heart rate variability, or HRV, serves as a primary indicator of this autonomic transition during periods of solitude. HRV measures the variation in time between consecutive heartbeats, with higher variability signaling a flexible, resilient nervous system capable of managing stress efficiently. In the absence of social observation, the heart's rhythm stabilizes into a more coherent pattern that reflects a high vagal tone. This phenomenon occurs because the vagus nerve, the longest nerve of the autonomic system, begins to exert a calming influence over the thoracic and abdominal organs once the brain perceives it is no longer being watched or evaluated. This physiological unmasking is essential for long-term cardiovascular health, as it provides a necessary window for the heart to recover from the microstressors of daily human interaction. Have you ever noticed how your natural breathing rhythm changes the moment you are truly alone in a quiet room? This shift in respiratory mechanics is a direct consequence of the parasympathetic system taking the lead. Without the need to speak or maintain a certain posture for the benefit of an audience, the diaphragm tends to move more freely, leading to deeper, more oxygen-rich breaths. These slower breathing patterns further stimulate the vagus nerve in a self-reinforcing loop of tranquility. Science for sleep often highlights this autonomic downshifting as a critical precursor to high-quality rest, as it lowers the baseline of cortisol and adrenaline that can otherwise linger in the bloodstream for hours after social engagements end. The biological necessity of this reset cannot be overstated, particularly in a world where digital connectivity often mimics the presence of a crowd. True solitude allows the prefrontal cortex to cease its constant performance mode, which in turn signals to the amygdala that the environment is safe. This reduction in amygdala firing is what facilitates the deeper physiological layers of the reset, moving beyond mere relaxation and into a state of neurological consolidation. By allowing the autonomic nervous system to cycle through these periods of parasympathetic dominance, the body ensures that the systems responsible for immune function, digestion, and hormonal balance are given the resources they need to function optimally. This period of quietude is a biological requirement for maintaining the structural integrity of the nervous system over a lifetime. Within this neurobiological landscape, the creative process thrives on a specific cycle of engagement and withdrawal. The 4 stages of creativity, as categorized by social psychologist Graham Wallace, highlight the incubation phase as a period where the unconscious mind takes over the heavy lifting. While the initial preparation stage requires intense, conscious effort to gather data and learn new skills, the incubation phase demands that this effort be entirely abandoned. Solitude provides the necessary environment for this transition to occur, as it removes the external stimuli that keep the conscious mind tethered to the present moment. In the absence of social interaction, the brain begins to shift its energy away from the task-oriented executive control network and toward the default mode network. This internal shift is not a sign of cognitive idling, but is instead a highly active state of synthesis and reorganization. Neuroscience has demonstrated that during these periods of solitude, the brain engages in a process known as unconscious processing, where it continues to work on problems without our awareness. This is why the most profound aha moments, the illumination stage, frequently occur when we are alone and seemingly distracted by a mundane task, such as walking or showering. When the mind is allowed to wander in a solitary environment, it is free to forge connections between disparate ideas that the rigid, logic-driven conscious mind might have previously discarded as irrelevant. The sheer lack of external input creates a vacuum that the brain naturally fills by reaching into its long-term memory stores, pulling forward old concepts to marry them with new information. Have you ever found that your most vivid ideas arrive in the quiet space, just before you fall asleep? This phenomenon is supported by research into the link between boredom and divergent thinking. Studies published in journals like the British Journal of Psychology have found that individuals who spend time in solitary, low-stimulation environments show a marked increase in their ability to generate original solutions. Boredom, far from being a negative state, serves as a signal for the brain to switch into a more creative, exploratory mode. In a world where every spare second is often filled by a screen, the deliberate choice to be alone and unproductive is a biological necessity for innovation. Without this quietude, the fragile architecture of a new idea can be easily shattered by the arrival of a notification or the start of a conversation. The neurochemical environment required for creative incubation is sensitive to the stress hormones associated with social performance. When we are around others, even people we like, a small portion of our cognitive capacity is always dedicated to social monitoring and self-presentation. Solitude eliminates this tax on our mental resources, allowing the brain's glucose and oxygen supplies to be redirected toward the complex work of neural restructuring. This restructuring is what allows a half-formed thought to coalesce into a coherent insight. The quietude of being alone acts as a protective shield, ensuring that the nascent synaptic connections forming around a new concept have the time and stability to solidify before they are tested against the outside world. By honoring this phase of the creative cycle, we allow the subconscious to complete its intricate work of weaving together the threads of human knowledge. The internal landscape of the mind shifts significantly when the external pressure of observation is removed, facilitating a process known as divergent thinking. This cognitive state allows the brain to generate a vast array of potential solutions to a single problem, exploring tangential paths that might seem nonsensical in a more structured environment. While convergent thinking focuses on narrowing down options to find the one correct answer, divergent thinking is the expansive, uninhibited act of mental branching. In a social setting, the human brain often defaults to convergent patterns because the group dynamic implicitly demands consensus. This pressure to agree or to provide the right response can act as a cognitive bottleneck, stifling the unusual or high-risk ideas that frequently lead to innovation. Research in social psychology identifies a phenomenon called evaluation apprehension, where the mere presence of others creates a subtle, persistent anxiety regarding how our ideas will be perceived. This apprehension functions as an internal editor, often deleting original thoughts before they are even fully formed to protect the individual from perceived social risk. When you are truly alone, this editor goes offline, granting you the mental freedom to entertain absurd hypotheses or unconventional associations. Can you recall a time when your most creative realization arrived while you were simply staring at a wall in a quiet room? This lack of monitoring allows for a form of unmonitored experimentation where the cost of failure is zero. Without the need to justify each step of the logic to an audience, the prefrontal cortex can engage in more flexible, associative play. Historical evidence suggests that some of the most profound shifts in human understanding occurred during periods of intentional or forced isolation. Isaac Newton's Annus Mirabilis, or Year of Wonders, took place while he was away from Cambridge University during the Great Plague, a period of solitude that allowed him to develop the foundations of calculus and his theories on optics and gravitation. Similarly, Charles Darwin spent years processing his observations from the HMS Beagle in the quietude of Down House, away from the immediate scrutiny of the scientific establishment. These breakthroughs were not merely the result of hard work, but of the specific mental freedom found in the absence of the groupthink that often characterizes dense intellectual circles. This solitude permits the brain to bypass the normative influence of the crowd, which tends to punish deviation from established facts or methods. In the laboratory of the lone mind, the standard rules of social physics are suspended, allowing the individual to weigh evidence based on its own merit rather than its popularity. This is where intellectual courage is born, in the quiet moments where the only witness to a radical new idea is the thinker themselves. By removing the distraction of social feedback, the neural pathways responsible for complex problem-solving can fire with greater synchronicity and focus. This state of mental sovereignty is essential for any task requiring deep conceptual reorganization, as it provides the safety necessary to dismantle old beliefs and construct more accurate models of the world. As the brain settles into this deep work, the boundaries of what is considered possible begin to expand, unencumbered by the expectations of the outside world. This suspension of external pressure creates the ideal environment for the flow state, a concept pioneered by psychologist Mihai Csikszentmihalyi to describe a period of total absorption where the sense of time and self seems to dissolve. When you are alone, the absence of social cues allows the brain to shift its resources away from self-monitoring and toward the task at hand. This autotelic experience, where the activity is inherently rewarding regardless of the outcome, thrives in solitude because there is no audience to perform for. Statistically, these moments of peak performance are far more likely to occur when you are working in isolation. Group settings often introduce a phenomenon known as process loss, where the cognitive energy required to coordinate with others detracts from the depth of the actual work. Solitary environments eliminate these interruptions, allowing the prefrontal cortex to maintain a singular focus that is otherwise fragile. Have you ever noticed how quickly a simple question from a colleague can shatter a complex train of thought you spent an hour building? Maintaining this state requires a delicate balance between the challenge of a task and your individual skill level. When these two factors align in a quiet space, the brain undergoes a significant neurochemical shift. A cocktail of performance-enhancing chemicals, including dopamine, norepinephrine, and anandamide, floods the system. These substances not only heighten your pattern recognition and lateral thinking, but also suppress the neural signals of physical fatigue or hunger. Research suggests that the lateral prefrontal cortex, which is responsible for our critical inner voice and self-consciousness, temporarily deactivates during deep flow. This transient hypofrontality is what allows for the effortless, non-judgmental execution of difficult tasks. Because there is no one around to judge your mistakes, the fear of failure is minimized, which in turn lowers cortisol levels and allows for more daring cognitive leaps. This biochemical environment is unique to the solitary mind because social interaction, even when positive, requires constant monitoring of one's own behavior. In the silence of your own company, that monitoring system goes offline, redirecting that massive amount of energy into creative problem-solving or artistic expression. Anandamide, in particular, helps the brain make connections between disparate ideas, a process that is often inhibited by the noise and expectations of a shared workspace. The beauty of the autotelic experience lies in its self-sustaining nature. The more time you spend in solitary flow, the more your brain craves that specific type of focused engagement. This isn't just about productivity. It is a fundamental reorganization of how the mind processes information and derives satisfaction. By removing the distraction of the other, you provide the brain with the necessary bandwidth to reach these heightened states of consciousness. As the dopamine levels rise during these periods, they reinforce the neural pathways associated with deep concentration. Over time, this makes it easier to enter flow states in the future, effectively training the brain to find joy in long periods of independent study or creation. This internal reward system is far more robust than external validation, leading to a more stable sense of self-worth and intellectual autonomy. The solitude becomes a laboratory for the mind, where the only variables are your skills and the challenge before you. In this space, the work becomes its own reward, and the boundaries of your capabilities are pushed further than they ever could be in a crowd. When we step away from the noise, our brain begins the silent, metabolic work of memory consolidation. This is a physical relocation of data from the fragile short-term stores of the hippocampus to the more permanent architecture of the neocortex. This transfer requires a specific neural environment that is largely free from the constant bombardment of social cues and linguistic input. When you are alone, the brain is able to shift its energy away from external processing and toward this internal structural stabilization. This process is essential for turning fleeting experiences into lasting knowledge. While you sit in silence, your brain acts as a diligent gardener through a process known as synaptic pruning. It identifies the connections that are weak or no longer serving a purpose and systematically dismantles them to make room for more relevant information. This selective elimination allows the remaining, more important pathways to strengthen, effectively sharpening your cognitive focus for the hours ahead. This biological offline time is a biological necessity for anyone attempting to master complex skills or navigate dense academic subjects. Do you find that your best ideas tend to surface only after you have stepped away from a group setting? There is a robust body of research surrounding the interference theory of forgetting, which posits that our inability to remember often stems from the sheer volume of competing information we face. When we move immediately from one social interaction to another, or from a lecture into a crowded environment, the new sensory data disrupts the stabilization of the facts we just learned. This is known as retroactive interference, where the arrival of new information actively hinders the retention of what came just before it. Solitude acts as a protective shield for the mind, allowing the encoding process to complete without being overwritten by the mundane details of social coordination. Research involving university students has demonstrated that those who take a quiet, 20-minute walk in solitude after a period of intense learning perform significantly better on recall tests than those who immediately engaged in digital media or conversation. This suggests that the brain requires a buffer of silence to cement new knowledge before it is overwrought by the next wave of external stimuli. During these moments of quiet, the brain enters the default mode network, a state where it can synthesize information and connect disparate ideas without the pressure of an immediate task. This isn't just about intellectual efficiency. It's about the fundamental way our neurons communicate. Long-term potentiation, the biochemical process by which synapses strengthen over time, thrives when the nervous system is not under the stress of constant reaction. By choosing to be alone, you are providing your brain with the metabolic space to finish the work you started during the hours of focused effort. It is in the absence of others that the brain truly learns to navigate itself, clearing away the clutter of the day to reveal the structures that matter most. This neurological maintenance ensures that when you return to the world, your mind is not just rested, but structurally more capable than it was before you sought out the quiet. These periods of rest allow the glymphatic system to clear away metabolic waste, ensuring the neural environment remains optimal for the high-level cognitive demands of learning and problem-solving. The transition from metabolic clearing to active imagination happens seamlessly when we allow the mind to drift away from the immediate environment. For decades, the act of daydreaming was dismissed by psychologists as a sign of intellectual laziness or a failure of executive control. We now understand that these moments of task-unrelated thought are actually a refined cognitive tool used to integrate past experiences with future possibilities. Researchers categorize this state as stimulus-independent thought, a process where the brain generates its own internal imagery and narratives. When you are alone and your attention turns inward, the default mode network engages in what scientists call constructive internal reflection. This specific type of daydreaming is distinct from rumination, which is characterized by a repetitive focus on distress or failure. Positive constructive daydreaming involves playful exploration and creative problem-solving, which has been linked to increased levels of trait mindfulness. This mental wandering acts as a biological rehearsal mechanism for the complexities of social life. By simulating potential conversations or emotional reactions, the brain builds a library of neural templates that can be accessed during real-world interactions. Do you find that your best ideas often arrive when you are doing something repetitive, like washing dishes or walking alone? This phenomenon occurs because the executive control network, which usually manages focused tasks, relaxes just enough to collaborate with the imaginative default mode network. In 2012, a significant study led by researchers at the Max Planck Institute for Human Cognitive and Brain Sciences revealed a counterintuitive truth about the wandering mind. The research showed that individuals with a higher working memory capacity are more likely to engage in daydreaming during undemanding tasks. This suggests that the brain is not failing to pay attention, but is instead utilizing its leftover processing power to work on more complex, internal goals. Neural imaging has shown that during periods of solitude, the brain exhibits distinct patterns of functional connectivity that are absent during group activity. In states of positive constructive daydreaming, the medial prefrontal cortex and the posterior cingulate cortex work in tandem to weave personal history into future intentions. This process of self-projection allows us to navigate the timeline of our lives, transforming a quiet afternoon into a period of intense cognitive preparation. Far from being a distraction, the capacity to retreat into one's own mind is a hallmark of sophisticated neurobiology. It is during these periods of mental solitude that we consolidate our identity and refine our goals. The brain uses this time to cross-reference new information with existing memories, ensuring that our internal model of the world remains accurate and useful for the challenges ahead. These simulations provide a low-stakes environment for the prefrontal cortex to evaluate different outcomes, effectively training the mind for real-world decision-making. By embracing the wandering mind, we allow our neural architecture to perform its most creative and integrative work, turning the simple act of being alone into a profound exercise in cognitive evolution. Solitude serves as a biological reset for the human nervous system. When we are around others, the amygdala, the brain's almond-shaped emotional processing center, remains in a state of constant vigilance. This vigilance is not necessarily negative, but it requires the neural architecture to continuously scan for social cues, microexpressions, and potential threats. Removing the social observer allows the amygdala's activity to decelerate, shifting the brain from a state of external alertness to internal maintenance. This cooling down effect is visible in functional MRI scans, which show a distinct decrease in metabolic activity within the limbic system during periods of deliberate isolation. By lowering the baseline of neural firing in these regions, solitude helps prevent the chronic oversensitization of our emotional responses. High arousal emotions, such as anger or intense excitement, often trigger the sympathetic nervous system, flooding the body with cortisol and adrenaline. In a social setting, the pressure to maintain social face often forces us into emotional suppression, a tactic that has been shown to increase cardiovascular stress and heighten the activity of the autonomic nervous system. Solitude provides the safe environment needed for these physiological spikes to subside naturally. Without the need to perform or react to a witness, the parasympathetic nervous system can reassert dominance, lowering the heart rate and stabilizing blood pressure. Have you ever noticed how the physical intensity of a disagreement seems to evaporate the moment you find a quiet space to yourself? Psychologists often refer to the emotional refractory period, a window of time following a provocative event where our perceptions are filtered through a narrow emotional lens. During this period, we are biologically less capable of processing logic or contradictory information. Solitude acts as a buffer that allows this refractory period to expire without further social reinforcement or escalation. This return to an emotional baseline is essential for objective reasoning, as it allows the ventromedial prefrontal cortex to regain its supervisory role over more impulsive, reactive circuits. Research indicates that individuals who regularly engage in solitary reflection recover from high-stress social interactions up to 30% faster than those who immediately seek social distraction. The process of affect labeling, simply putting a feeling into words, is significantly more effective in the absence of external noise. Research at UCLA has demonstrated that the act of naming an emotion reduces the response in the amygdala while increasing activity in the right ventrolateral prefrontal cortex. This internal dialogue requires a level of cognitive focus that is frequently interrupted in social environments. By analyzing an emotion in solitude, the brain transitions from experiencing a feeling to observing it as a discrete biological event. This shift effectively deconstructs the emotional power of the experience, turning a chaotic internal state into a manageable data point. There is a vital neurobiological distinction between emotional suppression and solitary processing. Suppression is an active, effortful attempt to hide or inhibit emotional expression, which often leads to rebound effects where the emotion returns later with greater intensity. Solitary processing involves a passive acceptance and active integration of the emotional experience. This integration allows the brain to file the experience into long-term memory with a reduced emotional charge. By giving the brain the space to categorize these events without the interference of social judgment, we build a more resilient and stable internal landscape. This mechanism is fundamental to long-term mental health, ensuring that our emotional responses remain proportional to the reality of our environment. Central to this stabilization is the concept of arousal homeostasis, which refers to the biological drive to maintain a balanced level of physiological and psychological activation. Every social interaction, regardless of its emotional tone, acts as a stimulant that pushes the nervous system away from its baseline state. Even joyful celebrations or engaging conversations require the brain to process a continuous stream of facial expressions, vocal inflections, and linguistic subtexts. This processing demands significant metabolic energy, and over time, the cognitive load begins to weigh heavily on executive functions. Neurological research indicates that both positive and negative social encounters consume similar amounts of neural bandwidth. While we often associate fatigue with conflict, the intense stimulation of excitement and laughter also triggers the release of dopamine and norepinephrine, which eventually leads to a temporary depletion of neurochemical reserves. Solitude acts as a cooling period for the amygdala and the prefrontal cortex, allowing these systems to recalibrate without external pressure. Do you find that you need a quiet hour after a busy social gathering to feel like yourself again? This recalibration is essential for lowering the signal-to-noise ratio within the internal circuitry of the brain. When we are constantly surrounded by others, the noise of external stimuli, the movements, the sounds, and the perceived expectations of those around us, can drown out the signal of our own internal states and intuitive insights. By stepping away, we effectively silence the static, allowing for a much clearer perception of our own physiological needs and cognitive priorities. A fascinating component of this recovery is the enhancement of sensory gating. This is the brain's ability to filter out redundant or unnecessary stimuli, a process that frequently becomes fatigued in crowded or high-pressure environments. When we spend time alone, the mechanisms responsible for sensory gating are restored. This means that when we eventually return to social settings, we are better equipped to focus on meaningful interactions without feeling overwhelmed by peripheral distractions. In our modern urban landscapes, the cumulative effect of sensory overload is a constant pressure on the human nervous system. The persistent hum of traffic, the flickering of digital screens, and the proximity of strangers create a baseline of high arousal that many individuals never truly escape. Solitude provides a necessary biological sanctuary from this relentless input, preventing the chronic elevation of cortisol levels that characterizes urban burnout. This intentional withdrawal is not a retreat from life, but rather a strategic restoration of the biological systems that allow us to engage with our environment more effectively. This biological restoration extends deeply into our social architecture, where the capacity to feel for others is surprisingly dependent on the time we spend away from them. While it seems paradoxical, the quality of our relationships often hinges on the deliberate gaps we place between interactions. This is because empathy is not an infinite spring. It functions more like a reservoir that can be drained through constant, high-stakes emotional labor. In clinical psychology and social neuroscience, this depletion is often categorized as compassion fatigue or secondary traumatic stress. When we are perpetually surrounded by the needs, emotions, and presence of others, the neural circuits responsible for perspective taking, primarily the medial prefrontal cortex, can become saturated and less responsive. The distinction between being antisocial and being pro-solitude is fundamental to understanding human psychology. Antisocial behavior involves a rejection or violation of the social contract, whereas pro-solitude is the active maintenance of the self to better honor that contract. Choosing to be alone is an act of social preservation. A 2024 study published in the Journal of Experimental Social Psychology highlighted that individuals who spent short periods in quiet reflection were significantly more likely to engage in altruistic behavior immediately afterward. Do you find that your patience for others changes after you've had a few hours of complete silence? This research suggests that solitude acts as a reset button for our altruistic impulses, allowing the social brain to cool down and regain its natural warmth. As you process these relaxing facts, consider that the brain requires a period of non-stimulation to integrate social information. During these moments of quiet, the brain transitions from external monitoring to internal processing, which is a vital component of science for sleep and cognitive recovery. This transition allows for the integration of social experiences, turning raw interactions into meaningful memories. Without this downtime, our interactions remain surface level, and our ability to provide genuine support to others diminishes. This is why many people find bedtime listening to be a helpful bridge, as it allows the mind to shift away from the social demands of the day and toward a state of internal reflection. Research from the University of Rochester indicates that autonomous solitude that is chosen rather than forced, shows a direct correlation with increased levels of empathy and lower levels of anger. By removing the immediate pressure to react to others, the nervous system moves out of a reactive state and into a reflective one. This is especially important for those in caregiving or high-interaction professions where the empathy reservoir is under constant pressure. When we are alone, we are not just resting, we are regenerating the very faculty that allows us to be human. Additional studies on charitability have observed that participants who practiced brief, intentional solitude showed a marked increase in their willingness to donate to charitable causes compared to those who remained in highly social environments. The period of reflection allows an individual to move past their own immediate stressors and recognize the broader human condition. Solitude provides the necessary space to develop a self-concept that is independent of others' opinions, which is a prerequisite for conscious, compassionate choice. In this light, being alone is one of the most pro-social acts a person can perform. Self-determination theory posits that autonomy is a fundamental human need, essential for psychological well-being and personal growth. When an individual is alone, this need is met through the unfiltered expression of their own will. Without the subtle pressures of social expectations, the brain shifts into a state of pure self-governance. This is not merely about doing what one wants, but about the alignment of actions with internal values. In the absence of others, the prefrontal cortex engages in a unique form of executive function that is uncoupled from social monitoring. Research published in the journal Personality and Social Psychology Review suggests that solitude provides a critical environment for developing a robust sense of agency. When you choose how to spend your time in private, you are reinforcing the neural pathways associated with self-initiation. Have you ever noticed how much more decisive you feel when there is no one else around to weigh in on your choices? This phenomenon occurs because the cognitive load of negotiation and compromise is removed. Making decisions without consultation allows the individual to experience the direct consequences of their actions, whether successful or not. This immediate feedback loop is vital for calibrating judgment and refining the internal compass. Solitary problem solving serves as a powerful mechanism for building self-trust. When an obstacle arises and there is no external authority to defer to, the mind is forced to rely on its own creative and analytical resources. Successfully navigating a complex task alone produces a physiological sense of mastery that is difficult to replicate in a group setting. This self-efficacy, as described by psychologist Albert Bandura, becomes a bedrock for confidence in more public spheres of life. The reduction of external validation seeking is perhaps the most profound psychological shift that occurs during periods of intentional solitude. In social environments, the brain is often scanning for cues of approval or disapproval, a process that can lead to a fragmented sense of self. By removing the audience, the locus of evaluation moves inward. You begin to value the process of an activity rather than its perceived outcome in the eyes of others. This shift from extrinsic to intrinsic motivation is a hallmark of psychological maturity. It allows for the development of interests and skills that are authentic to the individual's nature, rather than those shaped by cultural or peer pressure. Over time, this practice of autonomy fosters a resilient identity that is less susceptible to the fluctuations of social trends. The quiet space of being alone functions as a sanctuary where the self is both the architect and the occupant of its own reality. This internal locus of control is closely linked to lower levels of stress and higher life satisfaction. When you perceive yourself as the primary driver of your life's narrative, the impact of external stressors is significantly mitigated. Solitude acts as a training ground for this perspective. By intentionally choosing to be alone, you are exercising the most basic form of agency, the power to determine your own presence. This practice builds a psychological buffer, ensuring that when you do return to the social world, your actions are driven by choice rather than compulsion or the need for acceptance. The biological foundation of our social preferences resides deep within the reward circuitry of the brain, specifically governed by how we process the neurotransmitter dopamine. While popular culture often frames introversion as a personality quirk, it is fundamentally a matter of neurobiological sensitivity. Introverts possess a highly reactive dopamine system, meaning they require significantly less of this chemical to feel stimulated or satisfied. When an introvert is in a crowded, high-energy environment, their brain is flooded with more information than it can comfortably process, leading to a state of neurological exhaustion. This isn't a lack of social skill, but rather an efficient response to an abundance of external data. Extroverts, by contrast, operate on a different threshold of sensitivity, often possessing what researchers describe as a long dopamine pathway. Their brains are less responsive to the chemical, requiring a constant stream of external novelty and social interaction to achieve the same sense of reward that an introvert might find in a quiet conversation. This creates a physiological drive for movement and engagement. However, even for the most social individuals, the constant pursuit of dopamine can lead to a phenomenon known as reward fatigue. Have you ever noticed how a long period of high-intensity socializing leaves you feeling strangely hollow, regardless of your personality type? When we choose to be alone, the brain shifts its primary neurochemical currency from dopamine to acetylcholine. Acetylcholine is a neurotransmitter linked to the parasympathetic nervous system, facilitating states of calm, deep focus, and internal reflection. While dopamine drives us toward external rewards, acetylcholine powers the brain's ability to turn inward and consolidate information. This inner-directed pathway is shorter and more direct in the introvert's brain, passing through the frontal lobes where planning and problem-solving occur. Solitude allows this system to take the lead, lowering the heart rate and allowing the mind to synthesize complex ideas without the distraction of external stimuli. It is a common misconception that extroverts possess an infinite capacity for social engagement without needing periods of withdrawal. In reality, the prefrontal cortex, the area responsible for executive function, requires downtime to recover from the sensory load of social navigation. Even extroverts experience a social hangover when the sheer volume of external data exceeds their brain's ability to categorize and store it. Science suggests that everyone, regardless of where they fall on the spectrum, experiences a shift in brain wave activity during solitude, moving from high-frequency beta waves toward the more relaxed alpha waves associated with creative flow. By understanding these chemical levers, we can view the act of being alone not as a withdrawal from life, but as a necessary biological recalibration. The brain uses these quiet windows to trim excess neural connections and strengthen the ones that matter most. This process, often referred to as synaptic pruning or consolidation, happens most effectively when the brain is not occupied with the noise of other people's presence. Choosing solitude is essentially an act of neuromaintenance, ensuring that the machinery of thought remains sharp and responsive for the next time we choose to engage with the world. Under the current neuroscientific models of 2026, we now recognize that the recharge period is not just a metaphor, but a literal metabolic shift in how the brain utilizes its limited energy resources. This metabolic efficiency is particularly pronounced in individuals who possess a trait known as sensory processing sensitivity, or SBS. Scientists recognize that roughly 20% of the population carries the biological markers for being a highly sensitive person, or HSP. This is not a psychological disorder or a simple personality quirk, but a distinct neurobiological strategy that has been observed in over 100 different species, ranging from fruit flies to primates. In these individuals, the thalamus, the brain's primary relay station for sensory data, exhibits a lower threshold for sensory gating. This physiological reality means that environmental stimuli which others might naturally ignore, such as the faint hum of a refrigerator or the subtle texture of a fabric, are processed with far greater intensity and detail. For the highly sensitive brain, solitude acts as a critical biological regulator rather than a mere social preference. When we examine functional MRI scans of sensitive nervous systems, we see heightened activation in the insula, an area of the brain deeply associated with self-awareness and emotional processing. These individuals engage in what researchers call a deeper depth of processing, where every piece of incoming information is analyzed and categorized against an expansive internal library of previous experiences. This constant, high-level computational work consumes enormous amounts of glucose and oxygen, leading to a faster rate of cognitive fatigue. Have you ever noticed how certain environments feel physically heavy or loud even when they are technically quiet to everyone else? When sensory saturation occurs, the body enters a state of physiological stress that only quiet isolation can effectively resolve. The sympathetic nervous system becomes overactive, leading to elevated cortisol levels and a literal tightening of the muscular fascia. For those with high SBS, being alone is a non-negotiable medical necessity to prevent a phenomenon known as an amygdala hijack, where the emotional center of the brain overrides the prefrontal cortex due to sheer input volume. Integrating these relaxing facts into our understanding of human diversity helps us see that solitude is a form of neural hygiene. Science for sleep often highlights how these quiet periods allow the sensitive brain to consolidate deep observations into long-term memory without the interference of new stimuli. The evolutionary advantage of this trait lies in the pause-to-check strategy, which allows a portion of the population to detect threats or opportunities that others might miss. However, this strategy is only viable if the individual has access to regular periods of low-stimulation recovery. Without these gaps in social or environmental interaction, the sensitive nervous system risks chronic dysregulation of the hypothalamic pituitary adrenal axis. During bedtime listening, it is helpful to acknowledge that the overstimulation felt by sensitive people is a measurable result of the ventral attention network being constantly triggered. In a state of solitude, this network finally rests, allowing the default mode network to engage in the essential work of internal synthesis and creative problem solving. This transition is rarely instantaneous, often requiring 20 to 30 minutes of total silence for the sensitive brain to fully descend from a state of high arousal into a restorative baseline. Within this baseline, the brain finally finds reprieve from the pervasive psychological phenomenon known as the spotlight effect. Research pioneered by Thomas Gilovich and colleagues at Cornell University suggests that individuals consistently overestimate the extent to which their actions and appearance are noted by others. In a social setting, the prefrontal cortex remains on high alert, constantly simulating the perspectives of peers to navigate potential judgments. This egocentric bias creates a persistent sense of being watched, even when the surrounding crowd is largely indifferent. When you step into total solitude, this imaginary audience dissolves, providing an immediate and measurable reduction in performative pressure. Do you ever notice how your posture or facial expressions shift the moment you are certain no one is looking? This transition marks the suspension of the social self, a facet of the personality that is curated to meet perceived cultural norms or professional expectations. Without an observer, the cognitive resources previously dedicated to impression management are suddenly liberated for deeper processing. The biological impact of this liberation is significant, particularly regarding the endocrine system's response to social surveillance. Social evaluative threat, the fear of being judged negatively, is one of the most reliable triggers for the release of cortisol, the body's primary stress hormone. By removing the possibility of external evaluation, solitude acts as a physiological buffer, allowing cortisol levels to stabilize and return to a healthy equilibrium. This reduction in chemical arousal facilitates a more authentic state of being, where the nervous system is no longer bracing for a critique that isn't coming. As the perceived spotlight fades, a form of cognitive restructuring begins to take place within the mind. In the absence of an audience, the brain shifts its focus from external feedback loops to internal sensory experiences and personal narratives. This allows for a more accurate self-assessment, unclouded by the distortion of social anxiety or the desire for immediate approval. Psychologists often refer to this as a safe harbor for authenticity, a space where the individual can explore thoughts and behaviors that might be suppressed in a public forum. The quietude provides the necessary conditions for the ventral striatum and other reward processing areas to respond to intrinsic rather than extrinsic motivations. When the pressure to perform is extinguished, the brain can prioritize genuine curiosity over social survival. This shift doesn't just lower anxiety, it fundamentally changes the nature of the internal monologue. Instead of a frantic rehearsal of social interactions, the mind enters a state of fluid reflection, allowing the individual to reconnect with their baseline identity before re-entering the complex dynamics of the shared world. This restorative shift is amplified when the individual steps away from the built environment and into the natural world, a phenomenon deeply rooted in the biophilia hypothesis. First proposed by biologist Edward O. Wilson in the 1980s, this theory suggests that humans possess an innate, genetically encoded tendency to seek connections with nature and other forms of life. When we are alone in these spaces, the lack of social pressure allows this biological affinity to become the primary driver of our neurological state. Have you ever noticed how the specific silence of a forest feels fundamentally different than the silence of an empty room? This distinction exists because natural environments provide what environmental psychologists call soft fascination, a type of sensory input that captures attention without requiring the cognitive effort of directed focus. Unlike the sharp, demanding stimuli of a digital screen or a crowded street, The visual geometry of the wilderness is composed of fractals. These are complex, self-similar patterns found in the branching of trees, the veins of leaves, and the jagged edges of mountain ranges. Research from the University of Oregon has demonstrated that the human visual system is specifically tuned to process these fractal patterns with high efficiency, a concept known as processing fluency. When you observe these patterns in solitude, the brain's alpha wave activity increases, signifying a state of wakeful relaxation. This physiological response suggests that our neural pathways are optimized for the organic irregularities of the Earth, rather than the rigid lines of modern architecture. Beyond the visual, the very air of a forest contains chemical messengers that influence human biology. Trees and plants emit volatile organic compounds known as phytoncides, which serve as an immune defense system for the vegetation against insects and decay. When a person spends time alone among these plants, they inhale these compounds, which has been shown to increase the activity of human natural killer cells. These specialized white blood cells are crucial for the immune system's ability to combat tumors and virally infected cells. Data published in the journal Scientific Reports indicates that even a short period of solitary immersion in a wooded area can significantly lower concentrations of cortisol, the body's primary stress hormone, for several days afterward. The synergy between solitude and nature is often described through attention restoration theory, developed by Stephen and Rachel Kaplan. This framework posits that urban life requires constant directed attention, which is a finite and exhaustible resource. The resulting mental fatigue often manifests as irritability, distractibility, and decreased cognitive performance. Solitude in a natural setting provides the necessary conditions for this resource to replenish because the environment does not demand a specific response or a filtered social performance. In this setting, the brain can switch from the task-positive network to the default mode network, which is the neural system responsible for self-reflection and creative insight. Is there a particular landscape, perhaps a coastline or a specific trail, that seems to instantly quiet your internal chatter? This transition into restorative solitude is often most effective when the individual is physically removed from the symbols of their daily obligations. Without the visual cues of a workspace or the auditory interruptions of a city, the brain can more easily decouple from the stressors of the recent past. This is why nature is the most frequently cited setting for successful restorative solitude across various cultures. The combination of chemical exposure, visual fractal processing, and the activation of the biophilia response creates a unique physiological baseline that is difficult to replicate in any other context. By existing momentarily as a biological entity rather than a social one, the individual can reset their nervous system to its fundamental state. This biological reset transitions into a state of cognitive recovery that psychologists Stephen and Rachel Kaplan identified as attention restoration theory. To understand why solitude feels so replenishing, we must examine the limited reservoir of directed attention that governs our daily survival. Every time you consciously focus on a spreadsheet, navigate a crowded sidewalk, or inhibit a social impulse, you are burning through a finite metabolic resource managed by the prefrontal cortex. This effortful attention is vulnerable to fatigue, leading to irritability, poor judgment, and a significant drop in problem-solving ability. Have you ever noticed how a long day of socializing leaves you feeling physically heavy and mentally stalled? When we are alone, particularly in environments with low external demands, the brain shifts from this exhausting directed attention into what the Kaplans call involuntary attention. This is a bottom-up process where the mind is gently pulled by interesting but non-threatening stimuli, such as the way shadows move across a wall or the rhythmic sound of rain against glass. These stimuli provide soft fascination, a state where the executive system can finally go offline and begin the process of cellular and systemic repair. Because social interaction requires constant monitoring of facial expressions, tone of voice, and cultural norms, it acts as a persistent drain on the prefrontal cortex that only disappears when we are truly unobserved. Isolation functions as a tactical withdrawal from the inhibitory control required to function in a group. In a quiet room, the brain no longer needs to filter out the irrelevant speech of others or manage the complex data of interpersonal dynamics. This absence of pressure allows the directed attention mechanism to rest and recharge its depleted neural transmitters. Research published in the journal Psychological Science suggests that even brief periods of solitary reflection can significantly improve performance on subsequent tasks requiring high levels of concentration. It is not merely a lack of noise that aids this process, but the lack of a task-oriented environment that demands a specific response from the individual. The phenomenon of soft fascination is most effective when the solitary individual is exposed to patterns that are aesthetically pleasing but cognitively undemanding. While the previous discussion on fractals highlighted the physiological response to geometry, attention restoration theory emphasizes the psychological transition from doing to being. In this state, the mind wanders through its own internal architecture without the need to reach a conclusion or satisfy an external observer. This reflects a shift in neural dominance from the task-positive network to the default mode network, which is essential for synthesizing new information with existing memories. Recovering executive function through isolation is a measurable biological event, often resulting in lower cortisol levels and improved heart rate variability. By removing the social ego from the equation, the brain can prioritize internal maintenance over external performance. This restorative phase is why many people find their most creative insights occur during solitary walks or quiet moments before sleep, as the resting brain begins to connect disparate ideas that were previously suppressed by the demands of active focus. Once the directed attention resource is replenished, the individual returns to the world with a sharpened perception and a renewed capacity for complex thought. When was the last time you allowed your mind to drift for an hour without a single digital or social interruption? As we continue to explore the architecture of the solitary brain, we find that these moments of quietude are not empty spaces, but are actually periods of intense neurochemical reorganization. The auditory cortex never truly sleeps, maintaining a state of perpetual vigilance even during the deepest stages of non-REM rest. While your conscious mind retreats, this specialized region of the temporal lobe continues to monitor every vibration in the air, parsing mechanical hums and distant footsteps for potential threats. This constant monitoring means that our modern environment, saturated with the low-frequency vibrations of HVAC systems and urban traffic, keeps the brain in a state of low-level physiological arousal. Research published in the journal Environmental Health Perspectives indicates that chronic exposure to noise pollution can impair the brain's ability to regulate stress hormones, leading to a persistent elevation in heart rate and cortisol. Because the brain cannot simply close its ears, it must expend constant metabolic energy to filter out this background noise floor that defines our industrial age. When we provide the brain with true silence, the neurobiological response is transformative rather than passive. A landmark study conducted by regenerative biologist Imke Kirst at Duke University revealed that 2 hours of total silence daily led to the development of new, functional neurons in the hippocampus of mice. This process, known as neurogenesis, suggests that the brain uses periods of quiet to repair itself and integrate new information. The hippocampus is essential for memory consolidation and spatial navigation, meaning that the absence of sound acts as a catalyst for cognitive growth. If you find yourself seeking out a quiet room at the end of a long day, you might be responding to a deep-seated biological need for this hippocampal restoration. Have you ever noticed how the physical weight of a busy day seems to lift the moment you step into a space that is truly, deeply still? This brings us to the distinction between acoustic silence and informational silence, which is the total absence of words and symbolic communication. Deciphering human speech is one of the most computationally expensive tasks the human brain performs, requiring the rapid coordination of the temporal and frontal lobes. When we remove the need to interpret language, these circuits can finally disengage, allowing the brain to switch into its default mode network. This network is responsible for self-reflection, moral reasoning, and the synthesis of complex ideas. Without the constant stream of incoming verbal data, the brain begins to process its own internal states, a state of informational rest that is increasingly rare in our hyper-connected 2026 landscape. Curiously, the brain does not process silence as a void, but as a distinct and measurable auditory event. Functional MRI scans show that when a sound suddenly stops, the brain exhibits a burst of activity similar to its reaction to a sudden loud noise. This offset response indicates that the brain is actively listening to the quiet, treating the absence of sound as a meaningful signal in its own right. This physiological recognition of silence allows the auditory system to recalibrate its sensitivity, much like how the pupils of your eyes dilate to adjust to a dark room. By intentionally stepping away from the noise of the world, we aren't just resting our ears. We are allowing our entire neural architecture to return to a state of baseline equilibrium. This calibration is essential for maintaining the high-fidelity perception required to navigate the complex sounds of our daily lives. The foundation of this cognitive resilience begins much earlier than we might realize, rooted in the quiet corners of a nursery or a playroom. Early childhood development relies heavily on periods when a child is left to explore their environment without direct adult guidance. This solitary play is a critical cognitive milestone that allows a child to transition from merely reacting to external stimuli to actively creating their own internal worlds. When a toddler sits alone with a set of blocks, they are engaging in a sophisticated form of data collection regarding spatial awareness, gravity, and cause and effect. During these moments of seclusion, children frequently engage in what psychologists call private speech, a phenomenon where they talk themselves through complex tasks. Lev Vygotsky, a foundational figure in developmental psychology, noted that this audible self-talk eventually internalizes to become the silent inner voice of adult thought. This process is the bedrock of narrative skills. As the child begins to construct complex stories and scenarios that exist entirely within the theater of their own mind. Do you remember a specific imaginary world or a secret friend you created when you were very young? Solitude also serves as the primary laboratory for emotional regulation and the development of the self. When a child is given the space to navigate minor frustrations or periods of quiet without immediate parental intervention, they begin to develop the neurological pathways required for self-soothing. This ability to return to a state of calm independently is a strong predictor of psychological resilience in later life. Research published in journals like Developmental Psychology suggests that children who have consistent opportunities for autonomous play show higher levels of executive function and impulse control as they reach school age. As children mature, their social interactions shift from parallel play, where they play near others but not with them, to deep, solitary focus. This shift marks a significant leap in the brain's ability to sustain attention on a single task, which is the precursor to the deep work required in adulthood. If this focus is constantly interrupted by structured activities or digital distractions, the child may struggle to develop the flow states necessary for complex problem solving. The transition from being entertained to being absorbed is one of the most vital shifts in a human's early life. Modern parenting often emphasizes constant enrichment, yet the absence of unscheduled time can be surprisingly detrimental. When every hour of a child's day is filled with lessons or digital stimulation, the brain's default mode network rarely has the chance to activate. This network is essential for self-reflection and the healthy processing of social experiences. Boredom, far from being a negative state, acts as a biological catalyst that forces the mind to look inward for entertainment, fostering a sense of agency. Removing the blank spaces in a child's schedule effectively removes the opportunity for them to discover who they are when the world isn't watching. By protecting these periods of quiet, we allow the developing mind to build a robust internal landscape that provides stability throughout a lifetime. The adolescent years mark what psychologists refer to as the second individuation phase, a critical period where the mind begins the complex work of detaching from childhood dependencies to form a sovereign identity. During this transition, the physical environment of a private bedroom often functions as a laboratory for the self, providing a controlled space where a young person can experiment with different facets of their personality. Environmental psychology suggests that when a teenager closes their door, they are not merely seeking isolation, but are establishing a necessary boundary that fosters a sense of agency and ownership over their internal world. This withdrawal is a fundamental component of Peter Bloss's theory of adolescent individuation, which posits that solitude allows for the integration of a new, more mature ego. The biological reality of the teenage brain involves a significant restructuring of the prefrontal cortex, the area responsible for complex planning and personality expression. As the amygdala, the brain's emotional center, becomes increasingly reactive during puberty, the need for a quiet space to process intense feelings becomes a physiological requirement. Solitude acts as a cooling mechanism for this heightened neurological activity, granting the developing mind a reprieve from the social pressures that dominate the school day. When an adolescent is truly alone, they are free from the imaginary audience, a cognitive phenomenon where they feel as though they are under constant observation by their peers. Do you remember the specific feeling of relief that came with closing your bedroom door and finally being able to drop the social mask you wore all day? In the contemporary landscape of 2025 and 2026, the traditional sanctuary of the teenage bedroom is frequently disrupted by the digital tether of smartphones and constant connectivity. This state of interrupted solitude means that even when a young person is physically alone, their brain may remain in a state of high social arousal due to the psychological presence of their peer group. Research indicates that this lack of pure, unplugged time can hinder the default mode network's ability to engage in the deep autobiographical reflection necessary for a stable identity. Without these periods of disconnected quiet, the process of individuation can become fragmented, as the individual relies more on external validation than on an internally generated sense of self. Managing the balance between peer connection and necessary withdrawal is one of the primary developmental tasks of the teenage years. Science suggests that the capacity to be comfortably alone is a strong predictor of long-term emotional resilience and self-reliance. When adolescents are given the space to inhabit their own thoughts without interruption, they are practicing the essential skill of self-regulation. This solitary time allows the brain to synthesize social experiences and align them with personal values, a process that eventually leads to a coherent adult identity. By recognizing that the drive for privacy is a healthy biological impulse rather than a sign of alienation, we can better support the intricate journey of becoming a distinct and functional individual. This internal work, though silent and invisible, forms the very foundation upon which a person's adult character is built. As the biological landscape shifts during the later decades of life, the psychological architecture of solitude undergoes a profound transformation. Research into socio-emotional selectivity theory, pioneered by Stanford psychologist Laura Carstensen, suggests that as our perception of time horizons narrows, our social motivations pivot from expansive networking toward emotional regulation. This shift often makes being alone a deliberate, strategic choice rather than an accidental state of isolation. For many, the drive to acquire new and potentially stressful social information is replaced by a desire for depth and tranquility in familiar, quiet environments. Neuroscientific observations have identified what researchers call the positivity effect in aging brains. Unlike younger individuals who may experience heightened anxiety or a sense of missing out during periods of isolation, older adults often demonstrate a cognitive bias toward positive information and memories when left to their own thoughts. This allows solitary time to function as a restorative buffer rather than a source of distress. It is a period where the amygdala's reactivity to negative stimuli appears to diminish, fostering a more serene internal dialogue that supports a healthy state of mind for bedtime listening. Solitude in these years provides the necessary mental space for what psychologists term life review. This is the structural process of evaluating and integrating a lifetime of disparate experiences into a unified sense of self. By looking back on decades of events without the distraction of external noise, the mind can resolve old conflicts and achieve what Erik Erikson described as ego integrity. This internal integration is a key component of psychological well-being, turning hours of stillness into a productive period of character consolidation. Have you ever found yourself appreciating a quiet afternoon in the sun more than you did 10 or 20 years ago? It is vital to distinguish between this intentional solitude and the clinical reality of geriatric loneliness. While solitude is a productive, self-chosen state that supports emotional health, loneliness is a subjective feeling of social disconnection that can increase cortisol levels and cardiovascular strain. Science for Sleep often highlights how maintaining this distinction helps individuals use their quiet hours for cognitive preservation. Engaging in solitary intellectual pursuits, such as reading complex literature, gardening, or mastering a new craft, stimulates neuroplasticity even in the later stages of life. Recent longitudinal studies indicate that those who embrace high-quality solitude tend to maintain better executive function and memory recall as they age. These relaxing facts suggest that the capacity to be alone is not just a personality trait, but a significant health asset. By viewing the later years as a time for deepening one's internal world, the quiet hours become a laboratory for wisdom. This phase of life transforms the silence into a rich tapestry of reflection, where the noise of the world finally gives way to the clarity of the self. This internal clarity is what allows the aging individual to remain anchored and functional even as their external social circles naturally contract. The neurobiology of the late night and early morning hours offers a window into a specific type of cognitive processing that is nearly impossible to replicate during the social density of the day. As the sun sets and the blue light of the atmosphere fades, the suprachiasmatic nucleus, the body's master clock, signals the pineal gland to begin the secretion of melatonin. This hormone, while primarily known for regulating the sleep-wake cycle, also facilitates a subtle shift in the brain's default mode network. In the absence of immediate social demands, this network, which is responsible for self-reflection and autobiographical memory, operates with a unique freedom. This biological shift explains why nighttime solitude often feels more profound than solitary moments during the day. The brain is neurochemically primed for inwardness. The concept of temporal isolation describes the psychological state of being awake while the surrounding social world is dormant. During these periods, the brain experiences a significant reduction in social load, which is the subconscious effort required to navigate or anticipate interactions with others. When this load is removed, the prefrontal cortex can reallocate metabolic resources toward complex synthesis and creative incubation. For many, this is not merely a lifestyle choice, but a manifestation of their specific chronotype, a genetically determined internal timing system. Science published in the journal Nature Communications has linked variations in the PER3 gene to these distinct patterns of alertness, proving that for many individuals, the peak of cognitive performance occurs precisely when the external world is at its quietest. As the core body temperature reaches its circadian nadir, typically in the pre-dawn hours, the body's metabolic rate slows, yet the mind may experience a peculiar, crystalline sharpness. This state is characterized by low levels of cortisol, the hormone typically associated with stress and environmental vigilance. With cortisol at its lowest, the amygdala's reactivity is dampened, creating a sense of profound psychological safety. This allows for the exploration of complex ideas or memories that might feel too intrusive or overwhelming during the high-stimulus hours of the afternoon. Have you ever noticed how your perspective on a difficult problem shifts when you examine it in the total stillness of the early morning? This phenomenon is supported by the unique neurochemical environment of nighttime solitude, which favors logical processing over emotional reactivity. This environment provides a controlled setting where the brain can test internal models of the world without the constant interference of external data. It is a period of neural maintenance where the glymphatic system clears metabolic waste while the mind organizes the previous day's information. In this way, the solitary hours of the night serve as a biological necessity, allowing the individual to integrate their experiences into a coherent sense of self. Isaac Newton's most transformative insights into calculus, optics, and gravitation occurred during the Great Plague of London in 1665, when he retreated to his family home at Woolsthorpe Manor. This period of enforced isolation removed the social friction of Cambridge life, allowing his brain to enter a state of sustained cognitive flow. Historians note that his habit was one of relentless mental focus, often skipping meals or sleep while pursuing a single mathematical thread for days. This environment favored the intense concentration required to synthesize the inverse square law and the laws of motion. Henry David Thoreau practiced a more curated form of solitude, spending 2 years at Walden Pond to observe the mechanics of nature without the interference of 19th-century industrial noise. His journals reveal that his productivity was tied to the absence of neighborly interruptions, which allowed his executive function to prioritize long-form observation. Do you find that you think more clearly when the world around you is completely silent? The deliberate reduction of social stimuli appears to lower cortisol levels, which in turn enhances the flexibility of the prefrontal cortex during creative problem solving. Charles Darwin structured his life at Down House around a sandwalk, a path where he walked alone several times a day to process complex evolutionary theory. This rhythmic, solitary movement facilitated a psychological state known as incubation, where the subconscious mind works on problems while the conscious mind is loosely occupied. By limiting his social circle, Darwin managed the chronic stress of his health issues while maintaining a high output of scientific correspondence. This physical and social separation from the scientific community in London prevented him from being swayed by the prevailing biases of his peers. Nikola Tesla frequently claimed that the friction of social interaction interfered with his ability to visualize complex electrical systems in 3 dimensions. He practiced a form of isolation that bordered on sensory deprivation, working in darkened rooms to enhance his internal mental modeling. This practice likely reduced the background noise in his visual cortex, making his mental simulations more vivid and accurate. Tesla's documented ability to build and test motors entirely within his mind serves as an extreme example of solitary concentration. The monastic approach to deep work involves long stretches of seclusion to reach a level of focus that is neurologically impossible in an environment of frequent switching. Modern neuroscience suggests that every time a person is interrupted, it takes an average of 23 minutes to regain full cognitive immersion. Secular retreats, common among modern mathematicians and theoretical physicists, leverage this by creating environments where the cost of task switching is effectively zero. These retreats mimic the cloistered environments of medieval scholars who produced voluminous texts through the exclusion of external distraction. Albert Einstein often sought solitude on his sailboat, where the rhythmic nature of the water and the lack of human presence allowed him to engage in thought experiments. These periods of isolation are strongly correlated with major leaps in physics, as they allow for the synthesis of disparate data points into a unified theory. The solitary mind is better equipped to recognize patterns that are otherwise obscured by the constant stream of external stimuli. Research from the University of Virginia suggests that even 15 minutes of solitary thought can be difficult for many, yet it is during these times that the brain's default mode network is most active in problem solving. Barbara McClintock, the Nobel-winning geneticist, spent years in solitude at Cold Spring Harbor, which she credited with allowing her to identify jumping genes by focusing entirely on the internal logic of her data. This spatial detachment mirrors the cognitive shifts observed in the overview effect, a term coined by space philosopher Frank White to describe the profound psychological shift experienced by astronauts. When viewing Earth from the absolute isolation of orbit, the complex social hierarchies, borders, and conflicts that define terrestrial life seem to dissolve into a singular, fragile unity. In the same way, intentional solitude provides a psychological orbit, a vantage point from which the granular, often exhausting details of daily existence lose their sharpness and intensity. When we are deeply embedded in our social networks, the brain is constantly processing high-resolution data about status, social debt, and micro-interactions. However, increasing the physical distance from others triggers a fundamental change in our mental representations, moving from concrete, low-level details to abstract, high-level concepts. This cognitive shift is a core component of construal level theory, which suggests that psychological distance allows us to view our lives through a wider lens. In this state, The brain naturally filters out the noise of trivial anxieties and immediate social pressures to focus on long-term goals and overarching core values. Within the silence of that distance, there is a measurable reduction in what psychologists call social friction. Without the immediate presence of an audience or the perceived need to perform a specific identity, the neurological pathways associated with self-monitoring and social evaluation begin to rest. It is here that we find a strange, therapeutic comfort in our own insignificance. Just as the vastness of the cosmos makes individual failures or embarrassments seem minuscule, the quiet of being alone allows us to realize that most of our daily worries are merely temporary ripples in a much larger, more stable pond. This mental space creates the clarity required to solve complex personal dilemmas that are otherwise clouded by the emotional proximity of others. We stop reacting to the immediate, often frantic demands of our social environment and start navigating based on internal coordinates. Scientific research into the benefits of solitude has shown that those who regularly step back from the social web possess a higher degree of self-regulation and a more stable sense of identity. By removing the constant feedback loop of society, you are essentially recalibrating your cognitive compass. You aren't just escaping, you're gaining the altitude necessary to see the entire landscape of your life at once. This bird's-eye view transforms a cluttered mind into a navigable map, where the path forward becomes visible not through forced effort, but through the simple act of standing far enough away to see it clearly. Have you ever noticed how a problem that felt insurmountable in a crowded room suddenly feels manageable when you're walking alone in the woods? This isn't just a change of scenery. It is your brain reclaiming the authority of the overview effect to restore your sense of proportion and peace. While the biological drive for solitude remains constant, the cultural lens through which we view being alone creates a fascinating spectrum of psychological thresholds. In Japan, the concept of hitoritabi, or solo travel, has evolved from a niche activity into a celebrated movement of self-discovery and mental clarity. This cultural framework allows individuals to decouple from the intense social pressures of the collective, viewing time spent alone not as a sign of isolation, but as a deliberate act of refinement. Have you ever noticed how your own tolerance for solitude seems to shift depending on the social expectations of the people around you? In contrast, many Western individualist societies emphasize the autonomy of the self, yet they often paradoxically struggle with the stigma of being alone in public spaces. Anthropological studies suggest that collectivist cultures often have higher thresholds for what constitutes loneliness because their primary identity is rooted in the group, making brief periods of aloneness feel like a temporary relief rather than a permanent state. Conversely, in societies where the individual is the primary unit, being alone can sometimes feel like a failure of social integration, even when it is biologically restorative. This tension between the internal need for quiet and external cultural norms is perhaps best observed in the long history of the religious hermitage. From the desert fathers of early Christianity to the forest monks of the Theravada Buddhist tradition, solitude has been utilized as a controlled psychological environment to facilitate neuroplasticity and deep focus. These traditions suggest that by removing external stimuli, the brain is forced to reorganize its internal landscape, a process that modern secular retreats now mirror for burnout prevention. Across all these varied cultures, the physiological response to intentional solitude remains remarkably consistent, involving a reduction in cortisol levels and a shift toward the parasympathetic nervous system. We are currently witnessing a global demographic shift, with the World Bank reporting a steady rise in single-person households in nearly every developed nation. This trend is redefining the urban landscape as architecture and social services adapt to a population that spends more time alone than any previous generation in human history. As these solitary lifestyles become more common, the distinction between social isolation and productive solitude becomes a vital area of scientific inquiry. The loneliness epidemic is often discussed in the media, yet researchers distinguish this from positive solitude, where an individual maintains strong social bonds while choosing to spend significant time in their own company. This distinction highlights that the value of being alone is not found in the absence of others, but in the presence of oneself. The architecture of our environment subtly dictates the depth of our internal quiet, acting as a silent scaffolding for the mind's drift into solitude. When we step into a space designed for isolation, we are engaging with the evolutionary principle of prospect and refuge. This concept, fundamentally rooted in our survival instincts, suggests that humans feel most at ease when they have a clear view of their surroundings, the prospect, while remaining shielded from behind, the refuge. Environmental psychology research has consistently shown that spaces offering this specific balance significantly lower resting heart rates compared to open, exposed areas. Do you find yourself naturally gravitating toward the corner seat in a quiet cafe or the back row of a library? This preference is not merely aesthetic, it is neurological. Corners and recessed nooks provide a physical boundary that reduces the brain's need for constant peripheral monitoring. In an open landscape or a bustling room, the brain must process potential interruptions or social cues from a full circle of awareness. By tucking into a corner, we effectively cut that surveillance requirement by 3/4, allowing the amygdala to transition from a state of passive vigilance into a mode of recovery. This biological stand down is essential for the transition into deep, imaginative solitude where the default mode network of the brain can fully engage without distraction. The mechanical elements of our dwellings, such as doors and locks, serve as more than just physical barriers. They are psychological anchors. The act of closing a door sends a clear signal to the nervous system that the external world has been paused. In 2024 and 2025, longitudinal studies on residential design indicated that the perceived control over one's environment, the knowledge that an entrance is secured, is a primary predictor of how effectively an individual can engage in restorative activities. This sense of agency over a boundary provides a safety signal to the hypothalamus, suppressing the production of stress hormones even if the individual remains fully awake and active. Creating what personality psychologist Brian Little calls a restorative niche has become a vital strategy in the modern home. These niches are small, dedicated zones where sensory stimuli are intentionally dampened to allow for the replenishment of cognitive resources. Unlike a bedroom meant for sleep, a restorative niche is designed for conscious being alone, often featuring soft textures and low-contrast lighting to minimize visual noise. Research suggests that even 10 minutes spent within such a controlled, private architectural space can significantly reduce directed attention fatigue, the mental exhaustion caused by the constant demands of social and digital interaction. This spatial deliberateness ensures that the home remains a sanctuary for the self. Digital solitude is often a physiological illusion because the brain remains in a state of persistent social monitoring while connected to a network. MIT professor Sherry Tuckle describes this modern phenomenon as being alone together, a state where we occupy a private physical space but remain psychologically tethered to the collective. True solitude requires the total absence of communicative intent, a condition that is functionally impossible to achieve while holding a device designed for instantaneous response. When a smartphone is within reach, the brain must dedicate subconscious resources to inhibit the impulse to check for updates. Research published in the journal Social Psychology demonstrates that the mere presence of a smartphone on a desk reduces cognitive capacity, even when the device is powered off and face down. This occurs because the prefrontal cortex is constantly working to ignore the potential for social interaction or information novelty. When you choose to scroll through a feed during a moment of isolation, you are engaging in directed attention, which is the specific type of mental exertion that leads to cognitive fatigue. This process actively suppresses the default mode network, the neural circuitry responsible for self-reflection and creative synthesis. The default mode network functions most effectively when the mind is free from task-oriented goals, such as navigating an interface or processing an algorithm. In a study comparing phone-free solitude to phone-active isolation, participants without devices showed significantly lower levels of cortisol, the body's primary stress hormone. Digital inputs trigger microbursts of dopamine that create a feedback loop, keeping the brain in a state of high alert rather than allowing it to drift into a restorative state. Have you ever noticed how your sense of time changes when you leave your phone in another room for an hour? The cognitive load increases exponentially through a process known as context switching, where the mind must rapidly jump between its immediate environment and the fragmented digital landscape. It can take the human brain nearly 23 minutes to return to a state of deep focus or true mental quiet after a single digital interruption. True physiological rest is marked by an increase in heart rate variability, which indicates a healthy transition into the parasympathetic nervous system. This transition is frequently blocked by the blue light and high-frequency stimuli inherent in digital consumption, which signal to the brain that it must remain vigilant. Solitude is scientifically defined by the lack of input from other minds, a requirement that scrolling fundamentally violates. While the body may be stationary, the mind is being subjected to a bombardment of external perspectives, preventing the autobiographical planning that occurs during genuine downtime. This planning is how the brain organizes personal memories and clarifies future intentions without the interference of social comparison. Disconnecting is not merely a behavioral choice, but a biological necessity for the brain to perform essential maintenance on its own neural pathways. When we remove the digital tether, we allow the brain to move from a reactive state to a reflective one. This shift is essential for prosocial development, as the time spent in true solitude actually increases our capacity for empathy and deep connection when we eventually return to social groups. The absence of digital noise provides the necessary silence for the brain to process complex emotions and consolidate long-term memories. Without this disconnection, the mind remains in a state of perpetual shallow processing, never reaching the profound depths of restorative quiet that define the human experience of being truly alone. Despite the profound necessity of silence, humans remain fundamentally gregarious biological organisms. Evolution has hardwired the brain to seek out group membership as a survival mechanism, making isolation a complex double-edged sword in our modern world. Research in evolutionary psychology indicates that our ancestors' survival depended almost entirely on being part of a cohesive tribe, which created a neural architecture that views total, forced separation as a physical threat. If you have ever felt a profound sense of relief after a long day when you finally close your door and subscribe to the quiet of your own room, you are experiencing the first phase of a biological rhythm. This inherent sociality does not contradict the need for being alone. Rather, it sets the stage for a delicate internal balancing act known in psychological science as the oscillatory model. This model suggests that human well-being relies on a constant, rhythmic movement between social engagement and restorative withdrawal. Like the inhalation and exhalation of breath, we require the intake of external perspectives and the outward-facing labor of communication, followed by a period of quiet integration. In 2024, longitudinal studies highlighted that individuals who successfully navigate this rhythm report significantly higher levels of life satisfaction than those who over-index on either extreme sociality or extreme isolation. It is the movement itself that prevents the stagnation of the self. When we disconnect, we are not merely resting. We are recalibrating our internal compass so that we do not lose our individual identity within the collective consciousness. The specific quality of the time spent alone dictates the effectiveness of the subsequent social encounter. When solitude is chosen and utilized for self-reflection or deep cognitive work, it strengthens the medial prefrontal cortex, which is vital for perspective taking. This means that an hour of mindful aloneness can actually make you a more empathetic listener and a more present companion when you return to a group. However, this paradox requires intentionality. If solitude is used merely for passive consumption or mindless distraction, the restorative benefits are minimized. By cultivating a rich internal life, we bring a more substantial version of ourselves back to the table, making our community interactions more meaningful and less performative. We must be careful to distinguish this constructive solitude from the chronic isolation that triggers the body's inflammatory responses. While being alone provides fuel for the mind, prolonged loneliness, the subjective feeling of being disconnected against one's will, can be as damaging to cardiovascular health as chronic stress. The goal is not to escape society, but to enhance our participation in it. Solitude acts as a reservoir for sustainable community engagement, ensuring we have the emotional reserves to support others without reaching a state of empathetic burnout. This healthy oscillation ensures that the silence of the individual eventually becomes the strength of the community. When we unify these biological threads, a clear picture emerges of solitude as a foundational pillar of human health rather than a mere social absence. The brain thrives in these quiet intervals because the default mode network coordinates a massive internal reorganization that sharpens our cognitive edge for the days ahead. Research published in the journal Nature Communications highlights how the brain's social synapses actually strengthen when they are given the space to rest, proving that our capacity for connection is built during the times we spend alone. This holistic benefit extends downward from the gray matter to the very rhythm of the heart, where a reduction in chronic social stress leads to improved heart rate variability. By lowering the baseline of circulating cortisol, intentional solitude functions as a natural mechanism for systemic inflammation reduction. We often view health through the lens of activity, yet the stillness of the individual is where the body's repair systems find their most efficient tempo. Think of the last time you felt truly mentally clear. Was it in the middle of a crowd or during a moment of profound quiet? Within these moments, the shift toward alpha wave dominance creates a neurological environment that mimics the restorative qualities of deep sleep while we are still awake. This biological transition is not a luxury, but a preventative health measure that buffers the nervous system against the friction of modern life. When the prefrontal cortex is no longer required to process the complex emotional cues of others, it redirects that energy towards self-referential processing and long-term planning. The cumulative effect of just 20 minutes of solitary reflection each day can lead to measurable changes in the density of the hippocampus, the region responsible for memory and learning. We are witnessing a shift in how science views the social animal, recognizing that our biological hardware requires a dual-track existence of engagement and isolation. This compound effect transforms small daily doses of aloneness into a resilient shield for the psyche, ensuring that our mental acuity remains sharp as we age. Solitude essentially acts as a metabolic reset, allowing the metabolic waste of a high-stimulation day to be cleared through the calm of a focused, solitary mind. As we consider the profound reach of these physiological shifts, it becomes evident that the silence we seek is actually a vibrant, active state of healing and growth. This internal restoration suggests that choosing to be alone is not a withdrawal from life, but a sophisticated biological strategy for long-term maintenance. We are frequently conditioned to view social isolation through a lens of deficit, yet the neurological evidence points toward a restorative surplus that occurs when the social brain is allowed to idle. Embracing these windows of time grants the central nervous system permission to transition from an outward-facing defensive posture to an inward-facing constructive one. It is in this specific state that the brain effectively consolidates complex memories and refines its internal models of the physical world without the constant interference of external social cues. Modern cognitive science increasingly categorizes solitude as a significant cognitive luxury, a rare resource in an era defined by constant connectivity and algorithmic stimulation. When we treat our own company as a deliberate tool rather than an accidental void, we harness a specific capacity for deep work and emotional regulation that high-density social settings often inhibit. The prefrontal cortex utilizes these moments of quietude to integrate complex information, a process that is frequently disrupted by the minor stressors inherent in even the most pleasant social interactions. Have you ever noticed how your most creative solutions often surface when you are not actively searching for them, but are simply existing within your own space? Applying these neurobiological insights allows for a more intentional design of our daily personal architecture, ensuring that the brain's physiological need for quiet is met with the same rigor as our requirements for hydration or deep sleep. The profound beauty of one's own company lies in the functional freedom it provides for the default mode network to wander through possibilities that are purely personal and unconstrained by the demands of social expectation or performance. This serves as the biological basis for self-actualization, where the quieted mind becomes a highly efficient laboratory for the most complex questions of identity and purpose. As we move forward into the coming years, the science of solitude remains an evolving frontier that continues to remind us that being alone is a vital, non-negotiable component of the human experience. This state of being provides the necessary contrast to our social lives, creating a balanced neurological ecosystem that supports both resilience and empathy. If you find value in these calm explorations of the biological and psychological world, consider subscribing to continue this journey of learning together. Our collective understanding of the mind grows deeper with every focused moment of stillness we allow ourselves to observe and understand.